Good morning, my students. So today we can see the second part of antihistamines. So generally we have seen last class yesterday we have seen the various classification and common SAR, etc. and all we have discussed. Today we are going to discuss as per your the syllabus what are the requirements, what you want to study, especially in your particularly on as per your syllabus that is antihistaminic drugs and so anti receptors we have already studied. Then H1 receptors we have to study diphenhydramine hydrochloride and diamine hydrate, triphenylamine and chlorcyclazine, meclazine, buclazine and chlorpheniramine maleate, triprolidine, promethazine and cyproheptadine, azatidine, estimazole, loratadine, and cetirizine, cromolyn, sodium. So these all are the H1 antagonist. So you have to keep it in mind always. H2 H1 antagonist always we are using as a anti-allergic, anti-rhinitis or anti-emetic drugs. Okay. Next, you have to discuss is the H2 antagonist. So, what is the basic difference between H1 antagonist and H2 antagonist? So, H2 antagonist is an anti-secretory, anti-secretory agents, or especially, or else we can call it the anti-ulcer drugs. Example is the cimetidine, famotidine, and ranitidine. Another one is in and under this anti-secretory is this one gastric proton pump inhibitors. Example, omeprazole, lansoprazole, pantoprazole, and rabeprazole. So that we can discuss one by one. The first one yesterday we have seen the classification. Once again we can discuss. Why after the discussion we can go one by one. So first one is the basic classification of H1 antagonist receptor inhibitors like amino alkyl ethers, ethylamine derivatives, thiophene derivatives, imidazoline derivatives, and promethazine derivatives. Then second generation. So what is the basic difference between first generation and second generation? First generation having the capacity of penetrating blood-brain barrier. So what will happen? It will produce the sedation. And whereas in the second generation things are non-sedation. Why? Because it is not the capability of to penetrate the blood-brain barrier. Okay. So this one we can discuss one by one. Okay. First drug comes under this drug is it is a amino alkyl ether derivatives. So amino alkyl ether derivatives we know that is a it is having two aryl group and one carbon atom or oxygen or carbon or nitrogen atom and the ethylene bridge and a basic nitrogen atom. So that is a very important thing. So basically we know this aromatic group may be phenyl or substituted phenyl or heterocyclic for the good antihistaminic activity. The R must be that R must be it is a methyl or hydrogen. This R must be methyl or hydrogen. If double bond in between alpha and beta carbon atom of the propyl chain, drowsiness will be developed. In this compound, the asymmetric carbon atom is dextrorotary atomism is a more active drugs. So now we can see the structure of diphenhydramine hydrochloride. So you know the chemical name of diphenhydramine hydrochloride. It is a 2 diphenyl methoxy NN dimethyl ethylamine. Okay, so mainly it was used to antihistaminic drugs. Also, it is used for the antiemetic, antitussive, antimuscarinic, and sedative properties. So mainly this diphenhydramine hydrochloride is one of the major component for the famous formulation is Benadryl. You heard about the drug and it cough syrup. It is one of the major component for this thing. Now we can go for its synthesis. So it is synthesized from the precursor compound of this diphenhydramine hydrochloride is a diphenyl methane. Diphenyl methane we had to brominate presence of light. So what will happen? It will form diphenyl bromomethane. Okay, in that one we have to condensed with the beta methyl beta dimethyl amino ethanol. Presence of alkaline media 140 degrees centigrade we had to heat it. So what will happen is removal of one mole of hydrogen bromide. Okay, so what will happen? So we are getting is a dif diphenhydramine base. Okay, so what is our endpoint? We have to get the diphenhydramine hydrochloride. So what we had to do, this base we had to uh, treat with the hydrochloric acid. So finally we are getting diphenhydramine hydrochloride. Okay. So normally diphenhydramine is available in the hydrochloride salt, and while crystalline powder and water soluble, it must be stored in a light tight container. Okay. The next drugs comes under this category is diamond hydrate. Diamond hydrate. Okay, diamond hydrate, you can see the structure. It is a one part of diphenhydramine, and another part is the, what is that? It is a chlorotheophylline. Chloro 8 chlorotheophylline. So diamond hydrate is prepared from the diphenhydramine hydrochloride and 8 chlorotheophylline in the stoichiometric preparation 1 is to 1. 1 ratio and 1 ratio of diphenhydramine and 8 chlorotheophylline we have to prepare from this diamond hydrate, because this one it is one of the potent diphenhydramine hydrochloride. It mostly used as the anti-nauseant and motion sickness and radiation sickness, also for the nausea for the pregnancy. So these all are these two drugs comes under amino alkyl ether derivatives. Now the next one, it is ethylamine derivatives. Ethylamine derivatives, we know that is a some important drugs is triphenylamine. Okay, important drug is comes under this one is a triphenylamine is another important drugs comes under this category. This category. Okay, so ethylene diamines means, ethylene diamine, what is the thing? It is containing two aryl groups, and on nitrogen on ethylene bridge and and basic nitrogen. Tertiary, it must be the tertiary nitrogen. So the thing, what is the important things you have to remember in this tripenylamine? Because in the basic structure of ethylene diamine derivatives, it is containing aryl group by two parallel system yield significant antihistamine. Example tripenylamine. Substitution by paramethylene, methoxy, or chloro or bromo further enhance the activity. If in this one, if you are adding any chlorination or methoxy group, we are adding this R2 structure. So what will happen? It will get paramethoxy, if we are adding chlorine group, we are adding, or bromo group we are adding, further enhance the activity. Now all the compound have the must be two tertiary nitrogen must be there in this two carbon atom. See, one is here and another one is here. Okay, so in this structure, all the compound of this ethylene diamine derivatives have two tertiary nitrogen is separated by two carbon atom. This two nitrogen, tertiary nitrogen, is separated by carbon atom. Okay, mainly it is cause less side effects than diphenhydramine hydrochloride. Okay, it is a less side effect than this tripenylamine is a less side effect than the previous one. Now the next one is cyclosin derivatives. So cyclosin derivatives means what are the drugs comes under cyclosin derivatives, otherwise called is the piperazine derivatives. So piperazine derivatives means what are the drugs comes under in this one? Piperazine derivatives or cyclosin derivatives. It is containing many number of drugs like cyclosin, chlorocyclosin, meclacin, and buclacin. Okay, so here we have to study chlorocyclosin, meclacin, and buclacin. Okay, so what is the things? So cyclosin, and because this is the base structure, it is a piperazine. This is the basic structure of piperazine. These all are the basic structure of piperazine. Mainly this one is a symptomatic relief of the hay fever and urticaria. Mainly all this kind of drugs used in this piperazine derivatives, mainly treating for the symptomatic relief of hay fever and urticaria and motion sickness, and as well as nausea, vomiting, and resulting vertigo due to vertigo. So mainly we are using this drug nausea, vomiting for the resulting due to the vertigo. So now we can see the cyclosin. Cyclosin is the base structure of this one. Cyclosin is nothing but it is the IUPAC name for this one is 1-diphenyl methyl 4-methyl piperazine. 1-diphenyl methyl 4-methyl piperazine derivatives. Then chlorocyclosin is a substance that is 1-parachloro benzhydryl 4-methyl piperazine. What is the IUPAC name of this? Chlorocyclosin is 1-parachloro benzhydryl 4-methyl piperazine derivatives. Then meclizine. Meclizine is the this is the meclizine. This drug is 1 parachloro alpha phenyl benzyl 4 methyl benzyl piperazine derivatives. Then buclazine. So this all comes under uh, okay, this all comes under, it is a, see the structure, it is a piperazine derivatives. Okay, so mainly this drug, which is a moderate class of antihistamine, mainly it is using for the nausea, vomiting. Okay, nausea, vomiting, urticaria, hay fever, mainly vertigo, due to vertigo മൂലം ഉണ്ടാകുന്ന ഈ ഒരു അസുഖങ്ങൾക്കാണ് നമ്മൾ സാധാരണയായിട്ട് ഇത് ഉപയോഗിക്കാറുള്ളത്. Now we can see the next drug is alkylamine derivatives. Alkylamine derivatives means a chlorpheniramine maleate, phenyramine, chlorpheniramine maleate, bromophenyramine. This all comes under this category. So, what is the thing you have to study in this is this a monoamino propyl derivatives. Okay, so mainly what is the chemistry of this monoamino propyl or alkylamine derivatives are is a propylamine derivatives containing a asymmetric carbon atom. The dextrorotatory isomer exhibit the greater potency. In this unsaturated derivative, Z isomer is have more active, and introduction of chloro or bromo or in the benzene ring of phenyramine increase the potency. Okay, it is a increase the potency. There is a phenyramine is if you are introducing chlorine or bromine or any other halogen group is introducing the phenyramine, so increase the potency. That's why it is a chlorphenyramine. Okay, so it is used as antihistamine and effective treatment for the allergic rhinitis, vasomotor rhinitis, and mild urticaria and uh, angioedema. Okay, angioedema. Okay, then the next one is a triprolidine. Comes under this monoaminopropyl derivatives. Triprolidine is the another drugs. Okay, triprolidine is the another drug which is used for this one. Chemically, it is a 2,3 pyrrolidine 1 ill while 1 para toluene prop 1 il pyridine. This is a chemically it is a 2,3 pyrrolidine 2,3 pyrrolidine 1 il 1 para toluene 1 para toluene ill pyridine derivatives. This is the triprolidine. So triprolidine is one of the major ingredient for the one of the famous combination actifed. You heard about the term actifed. The combination of actifed is a triprolidine and pseudoephedrine. Okay, so that's one we are using for especially these allergic things. So we will see the structure. We will see the synthesis of triprolidine. There is a paratoluene ethanol, or else we can call it as a paramethyl acetophenone. Is treated with formaldehyde and pyrrolidine. So I think you can remember this reaction. It is a this reaction is application of managed reactions, right? It is a paramethyl acetophenone treated with formaldehyde and pyridol, pyrrolidine. It is a application of managed reactions. Okay, so what is the thing? It is a formation of aminoketone, formation of aminoketone. Okay, then it is treated with NU addition and hydrolysis. And okay, then what is happening? So it's a formation of the fused ring of this compound. Then is that we had to go and dehydration. So we are getting here is a triprolidine. So triprolidine is one of the potent antihistamine used for relief of hypersensitivity, including the urticaria, rhinitis, conjunctivitis, and skin disorder. So it's also, I told you it is a pseudoephedrine in combination with the pseudoephedrine and triprolidine is a very good treatment for the cough and common cold. Is the trade name of this drug is a we can say it is a mm, actified. Okay, so the next one is we have to see this one. It is a cyproheptidine. Cyproheptidine is that is a dibenzo dibenzocycloheptane derivatives. Okay, this is the cycloheptidine hydrochloride. The commonly or cycloheptene is commonly it is comes under dibenzyl sorry, dibenzocycloheptene derivatives. So because this one here it is using for the antipruritus, okay, and also it is used for the anti-serotonin and antihistaminic. Somehow this is the one of the cycloheptene is a if we are having this consuming more drug, it is obesity. Oh, so sorry. So yeah, okay. So that's a cyproheptidine, and you have seen it as a triploidy synthesis. Now the next generation of is a phenothiazine derivatives. Phenothiazine derivatives, it is possessed. It is a tricyclic system. This is a phenothiazine derivatives. It is a tricyclic system. Phenothiazine derivatives possess two or three carbon atom, three carbon chain bridge between basic phenothiazine nucleus. Also, it is contained in basic nitrogen and sulfur. It is different from phenothiazine is an antipsychotic series. So unbranched propyl chain is required. Unbranched propyl compound is required for this activity. Okay, so basically, thing we have synthesized this phenothiazine at our laboratories, right? So what is the ingredient we are using for that one? That is a diphenylamine and sulfur and iodine. You have to heat around 160 degree or 90 degree at sand bath. Okay, so phenothiazine we can synthesize. So normally uh, is synthesis, because here also we can see the synthesis diphenylamine we are using, either we can use iodine or aluminum chloride, and and sulfur. So we had heat by above 150 degrees centigrade at sand bath, so we are getting the phenothiazine, followed by we have to condensed with 1 chloro 2 dimethyl aminopropane hydrochloride in presence of sodium sodamide and alkaline. So we are getting the phenothiazine promethazine derivatives, promethazine. Then it is treated with the hydrochloric acids. You are getting is a promethazine hydrochloride. Promethazine hydrochloride. I told you it is apart from the antihistaminic and antiemetic activity, is a triangulator. This is using for the antipsychotic drugs. Antipsychotic drugs. The famous trade name of this promethazine is a promethazine hydrochloride is a Finargan is the famous trade name. So the next one is a astimazole. Okay, loratadine. These are the second generation. Mainly, these are the second generation drugs. Astimazole, loratadine, and chromalin, then cetirizine, azatidine. These all are the drugs comes under second generation. So, what is the problem with this second generation? Means it does not cross the blood-brain barrier. So what will happen? So it does not cross the blood-brain barrier, means what will happen? So you don't have any sedative effect. Okay. So the estimazole is the same thing. Then loratadine, we have seen. Then second. Okay. Mainly that thing is second generation antihistamine bind only the peripheral H1 receptor with no sedation because of poor CNS penetration and low affinity for the central histaminic or cholinergic or adrenergic receptors. They have no central action and are used for the treatment of allergic reactions. It is divided into two main classes. It is a piperazine derivatives, mainly piperazine derivatives and pyridine and piperidine derivatives. Piperazine derivatives we can say it is a piperazine derivatives. Cetirizine is the major drugs comes in. Cetirizine is the piperazine derivatives. Then we can see it is a pyridine or piperidine derivatives like we can pyridine derivative. We can see it is this one. We can see pyridine, then astimazole, and loratadine. Loratadine is a pyridine derivatives. Then chromalin. This is a fused drug. Okay, so mainly cetirizine we can see this the structure of cetirizine. First drug we can see the cetirizine. So it is a 2,4,4 chlorophenyl phenyl methyl 1 piperazine ethoxyacetic acid. The basic structure. This compound have the citron and relatively because of citron formation is there. So it is relatively polar and thus does not penetrate the blood-brain barrier. The advantage of this drug is once daily for dosing, rapid onset of action, and minimal CNS effect. No cardiotoxic when it is administered with imidazole or any other macrolide antibiotic. So it is a very interesting drug and it is used as an antihistaminic as and a treatment for various allergic conditions. Okay, various allergic conditions. Okay, the next we can see it is a loratadine. So loratadine is a pyridine and piperidine derivatives. It is a loratadine is an azo-isomer of the cyproheptadine and structurally related with the azatidine, and the replacement of methyl group of azatidine by corresponding carbamate and introducing 8th chloro substitutes preserve the antihistaminic action and reduce the CNS effect. Okay, this is the thing with the loratadine. Okay, then chromoline. So chromoline, you know the structure. It is a uh, mainly it is a nebulizer available in the form of nebulizer and aerosol spray for ophthalmic preparation. Mainly it is used for bronchial asthma, also the treatment of allergic rhinitis and histamine symptom, the mastocytosis. Okay, this is the drugs comes under second generation. So now we can go for the basic structural activity relationship, the common structural activity relationship of all these drugs, because we have seen various type of drugs like amino alkyl derivatives, ethylene diamine derivatives, thiophene derivatives, cyclic compounds, phenothiazine derivatives. Okay, so mainly the thing is what is the basic thing. However, it is now possible to derive some important conclusion with respect to the structural requirement of optimal activity and the pharmacological activity, namely first thing in the all the drug it is a in all derivatives the terminal nitrogen atom must be tetraamine, so it is exhibit the maximum activity. So we can see the most of the antihistaminic drug is having the terminal nitrogen must be the nitrogen must be tetraamine, so that's why we are getting the maximum activity. The second one is the terminal nitrogen may be uh, constant of the part of heterocyclic structure. Example, if you are seeing is a peribenzamin hydrochloride, aniline hydrochloride, these are the things. So it's the maximum activity we are getting. For the maximum activity, carbon chain between oxygen, and nitrogen, then the nitrogen atom must be the ethylene moiety. Okay, so it is a ethylene, it is attached with the ethylene moiety. However, long or branched chain combination give less rise a less potent analogues. And the interesting thing this one observed that is the phenothiazine hydrochloride molecule. Okay, the phenothiazine, two carbon chain linked with the isopropyl moiety, but the presence of phenothiazine group must exert the therapeutic effect with the each molecule. The introduction of halogen, chlorine, or bromine in the para position of phenyl function improve the antihistaminic activity in the phenyramine derivatives like chlorphenramine, bromophenramine, like that. The amongst the ethylene diamine analogues may be a potent compound have involved due to the inclusion of various groups on the second nitrogen atom of the chain. Such group may be either heterocyclic aromatic ring or isocyclic group. So hydrogenation of such compound leads to loss of activity. And the seventh thing is the nucleus of the antihistamine must be minimum two alkyl, aryl alkyl or aryl function group equivalent to the polycyclic ring. Okay, embedded polycyclic ring. Antihistamine exhibiting optimum isomerism related dextro and Leo is a superspread the Leo activity. Okay, example dexochlorphenramine, dexobromophenramine, dexo or Leo triprolidine. These are all the things. And another one is enhance the effectiveness of the antihistamine is essential for one of the aromatic moiety is alpha pyridyl, while the second substitution nitrogen could be either benzyl function of the substituted benzyl group or one of the isosters of the benzyl moiety. Example phenyl diamine and pyrilamine, and introduction of basic cyclic ring system by altering the position of dimethyl amino group also enhance the antihistaminic activity. Example, it is a cyclosin, chlorcyclosin, meclosin, buclosin, etc. So these are all about the H1 antagonist. So I will always you have to keep it in mind for antihistamine it is a The drug is related with the receptor based things. Is the H1 receptor, H2 and H3 and H4. So H1 is a, I told you it is a antihistaminic. Histaminic basically is the allergic, anti-allergic, antipruritic or anti-emetic drugs. Okay, the H2. Now the next one we are going to discuss about H2 H2 receptor antagonist. So what is the meaning of H2? Basically, these drugs we are calling anti-secretory drugs. Mainly, mainly these drugs like H2 receptor blocking. We are, because H1 also we can say it is a anti-secretory drugs. Okay, mainly for this anti-secretory comes under this H2 receptor antagonist. So medication used to for the heal or reduce the ulcer recurrence, including antacid, histamine, H2 receptor antagonist, proton pump inhibitors, okay, prostaglandin related compound, and bismuth salt and combinations. Okay, so mainly this type of H2 receptor antagonist. H2 receptor antagonist we are using for the peptic ulcer diseases and the Zollinger-Ellison syndromes, gastroesophageal reflux, and acute stress ulcers and erosions. So mainly we can see the H2 antagonist. Mainly H2 antagonist means cimetidine, ranitidine, and famotidine. Okay, cimetidine, ranitidine, and famotidine. And the second class of drug is a proton pump inhibitor. Now first we can see the H1 antagonist. Okay, so H2 antagonist like cimetidine, ranitidine, and famotidine. Okay, so this one is the H1. We have discussed that H1 and H2 receptor. This H2 receptor leads the increase, so because this we told you before, H2 receptors leads to the increased gas to secretion. Okay, so what will happen? Increases secretion of this acids in the isolated atria and and inhibition of isolated uterus. Okay, these effects are blocked by H2 receptor antagonists, which are now we are using for the peptic ulcer. So I told you it is a first drugs comes under cimetidine. This is the famotidine, and this is the ranitidine. You see the basic structure of all these structure. What is the basic structure of cimetidine? What is the basic structure of cimetidine? It is a it is a imidazole nucleus, right? It is a imidazole nucleus. And what about famotidine? Famotidine. What is the molecule? It is a thiazole. Thiazole derivatives. Thiazole derivatives is the furan derivatives. Furan, thiazole, and imidazole. Remember all these structures, basic structure of this cimetidine, famotidine, and ranitidine. Cimetidine is the imidazole derivatives. Famotidine is the thiazole derivatives, and ranitidine is the furan derivatives. This always you have to remember, otherwise you will get confusion. Okay, so mainly H1 receptors, H2 receptors, we can see the basic structural activity relationship is imidazole ring is not required for the, because here we can see imidazole ring, we can see thiazole ring, we can see, and furan ring we can see. So imidazole ring is not required for the competitive antagonism of histamine H2 receptors. Other heterocyclic also it is selectively. Example we can see here, instead of imidazole we are using the thiazole and furan. So it is enhance the activity. Okay, and the ring and in terminal ring and the terminal nitrogen should be separated by 4 carbon atom. The terminal nitrogen must be separated by the 4 carbon atom for the optimum activity. Isosteric thioether link also present in the some certain drugs. Thio, okay, it is a thio ether link also. See, thio ether link is also separated by this component, and the testosterone nitrogen is a containing function should be polar or non basic constituent is the maximum antagonistic activity. Okay, so this is the basic structure of cimetidine, famotidine, and ranitidine. Now we can see the uh, synthesis of cimetidine. So many number of synthetic protocols are available for cimetidine. So here we can see the first one. It is treated with ethyl 5 methyl imidazole 4 carboxylate. That is the basic compound we are taking. So precursor compound for the synthesis of cimetidine is the ethyl 5 methyl imidazole 4 carboxylate. Is a protonation followed by we have to okay followed by we have to add this. Okay, then we are getting this corresponding compound. Finally we are fused with various compound. Finally we are getting this is the protocol for the cimetidine. Okay, so mainly these are all the drugs we are using for the this cimetidine, ranitidine. Ranitidine, you know, this trade name, basic trade name is Zendag. Recently it is banned by government, ranitidine, because of using or ranitidine having some cardiac problem issues like that. That issue is still it is going. We don't know what is happening. And cimetidine, famotidine, and ranitidine commonly we are using for the treatment for duodenal and gastric ulcer or Zollinger-Ellison syndromes, heartburns, like things we are, and duodenal ulcer. So mainly we are using gastric and duodenal ulcer. We are using this H2 antagonist. Now we can go for the it is SAR. So that one already we have discussed. What is that? In that one is the H2 receptor antagonist is a result of the international modification of histamine structure, and it is a deliberate search of certain chemically related substance of it is act like a H2 receptors. Imidazole is not required because not only imidazole, we can see famotidine and ranitidine is having its thiazole and furantoin. So imidazole ring is not only required for the ring system of competitive antagonism of histamine H2 receptors, other heterocyclic ring like thiophene, thiazole, furan, it is enhance the potency and selectivity of the H2 receptor antagonist can be used. The ring and the terminal nitrogen must be separated by 4 carbon atom of optimum antagonistic activity. Sometimes we can see it is isosteric thioether link also present certain drugs like we can see famotidine and ranitidine, we can see thioester. And terminal nitrogen should be the polar and non-basic substituents for the maximum activity. In general, antagonistic activity varies the inversely with the hydrophilic character of nitrogen group. Okay, this is the except nitrogen, ranitidine and nizatidine. Now we can go for the next one, proton pump inhibitors. So proton pump inhibitor, it is a gastric acid secretion regulated by because mainly because this proton pump inhibitor എന്ന് പറയുന്നത് വെച്ച് കഴിഞ്ഞാൽ it is a gastric acid secretion because basically I told you this these two drugs like H2 receptor blocking agent as well as proton pump inhibitors we are using as a anti-secretory drugs. So mainly what is because main thing is we have to inhibit the secretion of gastric secretion of our body. Okay. So what is the main thing is proton pump is doing means the gastric acid secretion regulated by the functioning H hydrogen potassium ATPase pump present in the parietal cell membrane. It exchange the proton, so it is exchange the potassium ion. So inhibition of this pump act beyond the site of action of secondary messengers like calcium and CAMB and is independent secretogenous histamine and gastrin and acetylcholine. Thus, this pump is inhibitors block the basal stimulation of this structure. That is the basic structure, basic mechanism of action of this. Main thing is the this proton പൊട്ടാസ്യം എ ടി പി എസ് പമ്പ് ഓക്കെ മെയിൻലി അതാണ് ഇത് ചെയ്യുന്നത് അതിനെ നമുക്ക് ഇൻഹിബിറ്റ് ചെയ്യുക എന്നുള്ളതാണ് ചെയ്യുന്നത് അതെന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇറ്റ് വിൽ ബി എക്സ്ചേഞ്ചിങ് ദ പൊട്ടാസ്യം iron. So inhibition of this pump acts beyond the site of action, secondary messenger and the independent secretogenous histamine, gastric and acetylcholine. This acid pump inhibit the block, the basal and the stimulation of secretions. So four drugs we can comes under this: omeprazole, lansoprazole, pantoprazole, and omeprazole, lansoprazole, pantoprazole, and rabeprazole. What is the common base structure present in this? All this one, it is a benzimidazole. See, you can see all the structures having the benzimidazole derivatives. It is separated. This one is separated by yes, thio group is separated with okay. The fusion is happened sulfur. Thio group is attached with this one, right? Mainly all these drugs is we are using for the gastric ulcers, Solinger Ellison syndromes, and hyper secretory disorders. Okay, now mode of action. So already I told you there is a drugs are suppressed. These drugs are suppress the gastric acid secretion through the hydrogen potassium ATPase pump. The two major signaling pathways that are present with the parietal cells, that means messengers like cyclic AMP, dependent potassium, calcium, that respective receptors of the action are M3 and H2, muscarinic 3 and H2. These receptors are modulated through the respective ionic mechanism and elicited by the acetylcholine from the M3 and histamine from H2 receptor of release of gastric secretion mediated by hydrogen proton potassium ATPase. These proton pump inhibitors can act on these receptors and inhibit the proton potassium ATPase and reduce the activation of parietal cells to release the gastric acid. Okay, so that's all about proton pump inhibitors. This H2 receptor blocking agent and proton pump inhibitor, sometimes they may ask for 5 mark question. Okay, so that's all about antihistamine. Okay, hope you understand antihistamine. So in this session we have so totally in this two chapter because antihistamine 1 and antihistamine 2, the two different slides I have prepared and submitted you all. So in that one we have discussed mainly what is the difference between okay what is the H1 receptor, H2 receptor and H2 receptor and H4 receptor. But H3 and H4 is not much focused on your syllabus. So H1 and H2 only we are focusing. So you have to differentiate the H1 receptor and H3 two receptors. H1 receptor mainly I told you it is a allergic reactions. It is inhibit the allergic reactions. H2 is a anti-secretory over the gastric fluids. Okay, so that you have to keep in mind. Okay, thank you very much.